kind of throughout it. That is a species of our sea lettuce called Ulva. And this is Ulva californica. All right, Ulva californica is a little blade, doesn't get much bigger than that, but it is all over the place. We're going to see it everywhere. You often see it on the backs of limpets. You see it on barnacles. You see it in the rock, intermixed. It's a real common species we have. Right, and intermixed with this is if you were to go down and feel this stuff, it's really kind of like sandpaper. It's really rigid. We have several different species of coralline algae. Coralline algae, these are red coralline algae, are algae that, that build calcium carbonate skeletons. And the calcium carbonate skeletons, one of the things it does, it allows them to withstand a lot of disturbances. They can withstand some sand burial. It's historically been thought of as a strong anti-herbivory agent, although there's a new paper out of the University of British Columbia by Patrick Martone's group that suggests that might not be the case. It might not be anti-herbivory. But within this, you see this coralline. You see there's several species here, so we'd have to pull them up and look at them closely. When I was here with Patrick, I pulled up something in my hand. I said, "Oh, what's this?" He goes, "Well, there's like 5 things there." He's a coralline algal specialist. So have a feel for these things, and feel what they feel, feel kind of how rigid they are. Now, if you're a coralline algae, if you straight calcium carbonate, you're like a coral. And I just said it's a good way of kind of withstanding sand burial and waves. If you're a coral, you're gonna break, right? They don't like that very much. They don't, if you're solid and you get broken, it's not a good strategy. However, some of the coralline algae have these things called genicula, these bends, these elbows. And if you get down there and feel these things, you can actually start to move them around. And when we get to the red algae and we get to this order of algae, we're going to see these things have what looks like a calcium carbonate section, and then another calcium carbonate section, and a little connection between them that's flexible. The filaments, we're going to look at these filaments that run between them. And so this is something we call you can use the term geniculate or articulate. Articulate, you can articulate things. And we're going to have geniculate corallines and non-geniculate corallines. And non-geniculate coralline might look something like, oh, there we go, this. So look at this right here, this crust, right? This crust here, and actually there's some geniculate corallines right next to it, is a type of coralline that doesn't have those genicula, those bends to them. And so these are going to be 2 main kinds of coralline algae we have. These crustose ones can blanket the bottom. If you go to the Aleutian Islands, the crust can be this thick. They're great climate change things for climate change records. They live below the algae. They have very low metabolic demands. They are some of the deepest growing algae, the red crusts. Can grow up to almost 300 meters deep. That's almost 900 feet deep. And so we'll take a look more about those when we get into some of the ecology of these. But those are 2 of the main ones.